Hello everyone. In this video, we discuss our project titled Diabetic Retinopathy Detection System. This project is developed by a team of 3 members, Deep, Harsh and Jayan, under the guidance of our mentor Dr. Geeta Kasana as our B.Tech final year project. What is diabetic retinopathy? Diabetic retinopathy or DR is an eye disease which is caused by the damage to blood vessels at the back of the eye. It is the major cause of blindness among the people aged from 30 to 70 years. People affected from diabetes are more prone to diabetic retinopathy. Here we can clearly see the difference between the vision of normal eye and the vision of DR affected eye. 93 million. This is the number I would like to start this video with. More than 93 million people in the world are affected by diabetic retinopathy. I must also tell you that diabetic retinopathy is asymptotic in its early stages. That is, its symptoms are not visible in the initial stages. So, if it is not diagnosed at the right time, it may lead to permanent blindness. You can see it takes usually from 10 to 14 days to consult an eye specialist. Now, using our proposed system, the diagnosis time can be significantly reduced from 2 weeks to just a few minutes. Let's see how we do this. The solution is image processing and deep learning. In deep learning, a convolutional neural network is a class of deep feed-forward artificial neural network most commonly applied to analyzing the visual imagery. Here, we have used the convolutional neural network to detect the presence of diabetic retinopathy in retinal images. We have obtained our dataset from a well-known website called Kaggle. Kaggle is famous for hosting machine learning competitions. The dataset initially consisted of around 8,500 images. There is one interesting observation about this dataset. This dataset was initially imbalanced. The number of images that showed negative signs of DR were way more than the number of images which showed positive signs of DR. Hence, the first process in training our model in pre-processing our dataset was to balance the dataset. And we did so by rotating the number of images that showed the positive signs of DR. Let's get hands-on with some pre-processing. For the demonstration, we will show how we resize the images. We have taken 20 images for the demonstration. Now, as soon as we run the script, we can see a new directory being created. This directory now contains the resized images. We have cropped down our initial images to a size of 256 cross 256 pixels. These images won't take much time to train on our convolutional neural network. Now let's see how common internet users can benefit from our project. We have created a web interface. The web interface is user-friendly, it's very interactive. The user can upload the image of the retina. Now as soon as the user clicks the submit button, our model will run at the backend and it will predict whether the user has the disease or not. Let's see. Well, it turns out that this particular user is diagnosed with diabetic retinopathy. Now let's see how reliable our system is. Our system predicts the results with an accuracy of 91% when trained on around 2000 images. This accuracy is decent when compared with the accuracies of already existing systems. Now we will discuss the future work. If the technology enhances to an extent that the common smartphones are able to take retinal images, then a dedicated Android or an iOS app could be developed so that people don't even have to go to laboratories to get their retinal images scanned. Thank you. This was all about our project.